All right, guys, tell me what it means to bisect. What's that word mean? Just in general, the word bisect.
It's the line like in between the two angles.
It's in between the two angles. And if it's in between the two angles, what does that mean about the two angles? They're equal, right? So anytime you see the word bisect, think equal parts. Bi is going to cut two equal parts. So the fact that this BD here is a bisector, so this is BD. And it's an angle bisector, so it's creating two equal angles. The only angles that could possibly be equal here is this angle to this angle. So the problem's telling you it's a bisector, so it's telling you those angles are equal. Okay, then it says ABD is 2x plus 5, so that's this one. And CBD is 4x minus 9. Bisecting creates two equal angles. Yesterday we talked about 3 different ways to solve problems. Angle 1 plus angle 2 equals 180. Angle 1 plus angle 2 equals 90. Angle 1 equals angle 2. Which one's this? It creates two equal angles. Should I add them up and set them equal to 180?
No.
Does that look like a half circle if I color that in? No. Do I see a box? No. So I should angle 1 equals angle 2. So I'm going to take these two equations. 2x plus 5 equals 4x minus 9. Set them equal to each other. Okay, work to get the x's together. It doesn't matter if you subtract 2x or you subtract 4x. I think that's a preference. If I subtract 2x, I'm going to add 9. So I'm just doing this all in one step to save some space. So I end up with divide by 2. So 7 equals x, right? I might think I'm done the problem, but the question's saying, what's the measure of angle ABC? So let's think about what ABC is. This is like a really tricky one because it has a lot of parts. ABC is the big angle. How would I get that?
Angle 1 plus angle 2.
I'd actually have to find them, right? And then add them together. So what I'm going to have to do is I'm going to have to take this 7 and I'm going to plug it in here. So 2 times 7 plus 5. So 14 plus 5. All right, so that angle's 19 degrees. This should be 19 degrees too, but just let's make sure. So 4 times 7 minus 9, 28 minus 9, okay, 19 degrees. On their own, those two little angles are 19 degrees, but the green angle is the two angles together. So to find ABC, I would have to do 19 plus 19. So 38 degrees would be the final answer. That one was really hard. Did anybody get 38 degrees? Cool. All right, that one definitely is like taking what we know, right? The examples that we've done examples really similar, and then taking it one step further. So applying some knowledge. All right, would there be one like that on your test? Probably not. Okay, that's like a deeper level thinking problem, but it's kind of cool to think about like how to get there. All right, and then the next one, at the very end of class yesterday, we talked about the theorem called triangle sum theorem, and we learned that the 3 angles inside of a triangle equal 180 degrees. So I'm going to take all 3 of these angles, 8x minus 1 plus 3x plus 4 plus 3x plus 9, and I'm going to set that equal to 180 degrees. So we've got to combine our like terms first. We get 14x, and then in terms of, we get 9 minus 1 is 8, 8 plus 12, equals 180. All right, and we're just working through and solving for x by combining our like terms. Can't move that out of the way. All right, so 14x equals 168. I'm just gonna take this over here. 12? Alright, so x equals, it just says solve for x. Sometimes it might request a specific angle. There were no letters on this, which is why it didn't do that. But if this had like an A, B, C, and it said find A, C, B, you would find angle C, whatever the middle one was, alright? So this is just a little bit of a summary of some stuff that we learned yesterday. If you bring your attention to the backboard, I wrote down all of the angle relationships that we've learned so far. The first 4 are what you learned yesterday. A linear pair, a complementary, a vertical triangle, something. Today we're gonna hit on the last one, which is called exterior angle theorem. And then you'll have all of the pieces that you need for at least this section. I am looking at your unit testing next Friday, so there is a lot more to do, okay? But not as much in terms of like the little vocabulary words that we've been doing. So today we are going to be in our toolkit and then eventually back into our workbook for a quick closure. So you need both of your copies out today. This is your toolkit on page 6. We did the triangle sum theorem yesterday. So we're adding in this exterior angle. Now I have 2 definitions here. You don't have to write both, but sometimes it's easier to put it in like non-geometry terms. So the first one is using geometry terms. The second one is more like your basically English language, okay? So exterior angle says that the sum of the 2 non-adjacent interior angles equals the exterior angle. That might sound confusing to you. So here's what that means. In other words, your interior angle plus your interior angle equals your exterior angle, as long as the 2 interior angles are not the angle directly next to the exterior angle. So hopefully that will make more sense when you see an example. But take a few moments, jot that down. Let's make sure we understand what the word interior and exterior mean. Of the 3 angles that you see on the board, all of them have numbers, for example, 4. Which one's the exterior one? 1, right? Exterior means outside. So an exterior angle will be found outside of the triangle versus inside. So this theorem says that the 2 inside angles equal the outside angle, as long as the inside angles aren't next to it. So for example, this angle right here cannot be used in this theorem because that purple dot is right next to that 1. Does that make sense? The 2 angles that you use can't be directly next to the 1. The rule doesn't work for that. So it's the other 2, the ones not touching it. So I can't use this angle here. So this theorem is saying then, okay, interior angle 1 plus interior angle 2 equals exterior angle, okay? So interior angle 1 plus interior angle 2 equals, we'll call it angle 1. It's not 1 degrees, it's like the name of the angle. So angle 1 is 98 degrees. Interior angle 1 plus interior angle 2, as long as the exterior, the outside angle, is not next to the inside angle. That it won't work if that's the case. I just want to move this out of the way. All right.
Wait, so what do you do if it is?
So if it is, we know that the triangle sum theorem, right, says that there are three angles inside of the triangle equal 180. So if you know two, then you can always find the third. Does that make sense? Does everybody it was a good question. Does everybody understand that? Like if I had x, then I could find the other angle by subtracting the 2 from 180, like we did for the third problem in our warm-up. All right, so let's look at this next one. So the angle I would not be able to use in this theorem is this one, because the 124 is my outside angle. I wouldn't be able to use the one directly next to it. So I'm crossing that one off. X probably isn't the best thing to use here, because you might be thinking I'm solving for that. But I'm saying, like, we can't use that one. All right, so this theorem says that the two outside or the two inside angles, as long as they are not the next two angles, equal the outside angle. So inside angle 1 plus inside angle 2 equals outside angle. And then this creates an equation that I can solve for that angle 2. So 65. I have space to write. All right, so I don't know what this question's saying because this box is blocking it. Is it saying what's angle?
Yeah, 2.
2. All right. So angle 2 equals 65 degrees. So just one new rule to add to our list. I have it written on the backboard there. Interior angle 1 plus interior angle 2 equals the exterior angle 3. I think there's some more examples in your toolkit. Now these ones just involve more algebra, but it's still the same concept. So the key to this type of problem is this rule only works if you're not using this angle, right? The exterior angle is the outside angle. That's the 122. I can't use the one next to it. So I just have to use the other two. So the inside angle 1 we'll call x plus 25, plus the inside angle 2 we'll call x plus 17, equals the outside angle, which is 122. So if we're combining like terms here, we've got 2x, because x plus x, plus 42 equals 122. Everybody okay with that so far? All right, and now I'm just going to work to get x alone. So I'm going to subtract 42. Divide by 2. X equals 40. Now the question doesn't say find x though. It says find DLH. So let's think about what that means. DLH. DLH is the purple dot. Do you see that? What do you think I'd need to do to find that purple dot?
Plug in x for D and H and then subtract by 1.
Good. Let's plug in and at least find these angles, right? So this angle here is going to be 40 plus 25. So this angle up here is going to be 65 degrees. And this angle right here is going to be 40 plus 17. So this angle is going to be 57 degrees. I know that the three angles that are inside of the triangle equal 180, and I have 2 of the 3. The purple dot is what I want. It's the third angle inside of the triangle. So 65 plus 57 plus that third angle equals 180 degrees. Because now I'm working my way inside the triangle. This has a lot of pieces to it. Does that make sense? Lily, it looks like you just did it. Can you tell me what it is? Am I catching you off guard? I just saw you type something in your calculator. Did anybody solve for this? Tell me what you get. Nate, what'd you get?
58.
58 degrees. Why don't you guys try the next one? Take a moment, see if you can do it. Inside angle plus inside angle equals outside angle. Start that part. Inside angle plus inside angle equals outside angle. Anybody think they know what PRQ is? You worked your way through the whole picture and you got that final answer.
76.
76 is correct. PRQ is this question mark angle, okay? So if I do inside plus inside equals outside and I work my way through that picture, I get X is 11. I plug X is 11 into this one missing angle and I get that that missing angle is 40 degrees. So then I'm going to take 64 plus 40 plus that last angle and set it equal to 180. And so we get 76. All right? So the last thing I'm going to have you do today is just try one full example problem on your own. It doesn't involve a lot of like X algebra. You're just solving, okay? So I am looking for you to do workbook page 31. I'm always concerned that I'm picking the wrong page in this packet.
I think you did.
I picked the wrong page. I always feel it.
There's 7 on
Okay. Let me see what I'm thinking. Here's some triangles. It's definitely this page. Page 20. Right? Yes, page 20. Top right number, page 20 has this example. It's number 7.
I think it's 31.
I changed the packet so many times over the years. That's why there's so many numbers on the bottom that I feel like I never have the right number for this one. I really just need to start this packet all over again, but I'm lazy. All right, so page 20, number 7. See if you can work your way through that problem. You're finding both angle 1 and angle 2. for this particular problem, it does not matter which one you solve for first. You could look at this triangle here and say, I have 2 out of the 3 angles inside of a triangle, right? So I can do angle 1 inside plus angle 2 inside plus angle 3 inside, which is actually angle 2. The 3 angles inside of a triangle add up to equal 180. All 3 of those angles are inside of the triangle, okay? To solve for the outside angle, I know that inside angle 1 plus inside angle 2 equals outside angle, as long as you're not using the one next to it, right? I can't use angle 2 paired with that outside angle for that formula. So those are the 2 equations you're solving. Anybody feel confident in their angle 1? What'd you get, Gabe?
108.
Yep, 108 sounds good for angle 1. Anybody feel good in their angle 2? What do you got, Brielle? 72 sounds good. So we're just combining like terms here. And same thing over here. And then just solving. So that's where the 72 is coming from. All right, so that applies basically the 2 things in triangles that I wanted you to know. What we talked about yesterday, 3 angles inside equal 180. What we talked about today, our outside angle equals our 2 inside angles. What do we think? Painless, maybe? It feels like a Friday, but I'm actually gonna see you guys tomorrow. Last day, so. Homework. I went in and filled in checked the Canvas assignments, and there were a decent amount of zeros for last night's Canvas assignment. I don't know if that's because you forgot to do it, you missed it on the front board. Just know that those Canvas assignments are open for the rest of the semester. So if at any point you do it, it will filter in overnight, okay? I'm not going to filter it in. So if you decide to do it next block, you're not going to see it until tomorrow. Okay, so at 11:59 p.m., Power School will automatically update that. So you can go back and do those assignments at any point, okay? And then also there is a Math Excel. It's going to be due next Thursday, a week from today. There's a lot of questions on this Math Excel, but a lot of them are just vocabulary based. You don't have to do work for them. So I think it's like 30 questions, which sounds like a lot, but the first 15 are like multiple choice vocabulary, okay? So just keep that in mind. It's there. It's a decent amount of questions. It's going to be due next Thursday.